Hello guys, and welcome to the next workshop in the Cybersecurity Reloaded series. So this workshop is going to be on DNS poisoning. It's by me, and some slide material is adapted from one of our professors on campus. So what is DNS? DNS stands for Domain Name System, and it turns basic domain names into IP addresses. And IP addresses are basically the actual location of the server. And so when you type in google.com, the internet or your browser doesn't know where google.com is or where the server that hosts the google.com web page is, but it knows, but it can ask a specific server, but it doesn't know which server to ask because it does not know the IP address of the server. And so what domain name systems do, they turn this name into an IP address like this. So there are basically two parts to the system. So when the client enters www.google.com into the address bar, they issue a DNS query request. And so there's a domain name server somewhere out there in the world, and this request is sent to that server right there. Then that server returns the IP address associated with that name, google.com. There are two different types, or two different terms I want to clarify. So binding is when you register for a domain name, you're binding the domain name with the actual IP address of your server. Resolution is when the client sends a query request and the domain name server returns the IP address based on the domain name. That's known as a DNS resolution. So how does it work? So let's say I want to go to penguins.cs.princeton.edu. So it first looks at the last part because the naming system is hierarchical. So it goes to edu, to the edu server, just root, the actual root name server, to talk to the edu name server right here. And then it gives it back princeton.edu. Then it goes to the Princeton name server, and then back, and then to the CS name server. And so that's where it gets the IP address from here, but it had to go all the way from the root to the edu and so on. At each stage, caching is used. So let's say cache was removed for the edu. So then it went to the edu and came back, and it went here, Princeton, and this guy recognized this request before, and so it just automatically returned this IP address right here and said, oh, I have that IP address. You don't have to go to this one. And then it goes here and then back. It's also cached here and also cached here. In this cache, there's a field called TTL. It's called time to live. Basically tells you how long that domain name is alive, as in you can use that domain name and that IP address to visit that web page. So let's look at some security issues. The wrong binding itself, when you're registering for it, let's say it got messed up, then you could just, it automatically goes to a different IP address and results in a different IP address resolution. Another one, an attacker could spoof a DNS reply, and this is known as DNS spoofing. So when the client issues a DNS query, then Trudy could reply saying, oh, here's the web page you're looking for, or the IP address of the web page you're looking for. And so this becomes pretty hard. This becomes harder with the DNS security extensions. So basically, at every step here, there's this gives a public key of the next one, and then a private key of the next one, and then so on. And that's to protect it so that you can't do a man-in-the-middle attack. And that's through SSL. That's where you say when you're on the URL page, it says HTTPS. So that's HTTP secure. And so that gives you an SSL certificate based on your specific domain name. So if I reply this for HTTPS web pages, it'll just say, or some browser will just say, oh no, you can't do this. It's the wrong web page, wrong DNS. These DNS security extensions only validate the DNS replies, but that's it, not the query. So that's one attacking point. Okay, so we're gonna try something out. I'm gonna give myself a man in the middle attack. So we'll have this. Can you guys see this? Yeah, okay. So basically, let's go to, oh, I'll do this, Ettercap G. So I have this. I click yes, WLAN 0. I scan for hosts. My, oh, shoot. Oh, that's right. Host list. My laptop right here is 10.0.21, and then the gateway is 10.0.0.1. And how you find that out? It's pretty simple. You just do route, and that's your right there, gateway right there. Your IP address, by the way, is right here, or your local IP address is right there. This is all local, so it will only work on your local machine. You can try to move it towards a external way if you want. Okay, so this is mine, and this I'm going to add to target 2, and then this one I add to target 1, and then I'm going to click on this ARP poisoning, sniff remote connections. Oh, and then okay, plugins, manage plugins. I'm gonna click on DNS spoof. I already set some configuration before, so we'll see how it goes. Unified sniffing. So if I go here,